Welcome to the second example of hypothesis tests for proportions. I hope you've seen the first video. This one is more just designed to tell you about two-tailed tests and how to calculate the p-value because it does change. The rest of those 6 steps that I looked at the other day are still good and we'll still use those. Now again, the first step is to identify that this is in fact a hypothesis test question. This question uses the word level as the very last word. So that's telling me I need to run through the 6 steps. So the first step, identify the hypotheses. H0 or the null and H1 or the alternative. Then what parameter are we testing? Not always, but usually when they start throwing out percentages, that's a good hint that we're doing proportions. Means will be more obvious because they'll usually say the word mean or average, and this one does not say mean or average. Now, what number are we testing it against? This one could get confusing. We have 2 percentages that would be tempting to pick from. Pick the one that does not come from the sample. Notice that the 15% comes from a sample of 100 restaurants, so we don't want the 15% in our hypotheses. We want to use the 0.2. And this one is also either a little easier or a little harder depending upon your point of view as you look for those inequality words. We don't have a less than and at most and at least, fewer than, but it says 20% have a policy. In other words, exactly 20% or equal to 20%. And the complement of that is not equal to. The nice thing about this is this means that the book and the way that I did in the last example both agree because the null has the equal to part. And 20% have a policy, so the null in this case is the claim. Step 2, going back to my list of steps, identify the distribution, that is draw a picture. Since it is proportions, it's still the standard normal, that nice bell-shaped curve with a mean of 0. Not equal to, I would recommend that you just memorize is a two-tailed test, or if you prefer, not equal to means you could be not equal to and less than, or you could be not equal to and more than. Just like confidence intervals, when you have a two-tailed hypothesis test, those two tails should be the same size. Again, your picture doesn't have to be perfect, just get the point across. Since we are doing proportions, we're going to use the Z for the standardized test statistic. One of the problems with a two-tailed test, it doesn't happen anywhere else except for two-tailed test, is that I don't know if I should put the Z over here on the left or if I should put the Z on the right. Put it wherever you want to. I'll leave it here on the right, but you might have to come back and adjust that. Just be aware of that. Step 3, calculate the standardized test statistic, and we have the same formula, and this, by the way, is step 2. So for step 3, we have Z equals P hat minus P divided by the square root of PQ over N. So P hat, we talked about earlier, comes from the sample, it's 0.15, minus the P comes from the hypotheses. And the sample size in this case was 100. So let's calculate that. So 0.15 minus 0.2 divided by square root of 0.2 times 0.8 divided by 100. And in a very abnormal case, we actually get a very nice number, negative 1.25. We don't even have to round it. Now, before I go on to step 4, I'm going to talk about step 2 again. I mentioned that you could label either the left-hand side or the right-hand side. Looking at my standardized test statistic, notice that it is negative, which means I should have labeled the left-hand side. So I'm going to erase that Z on the right-hand side and put it on the left-hand side. And that will make a difference in my calculation in step 4 for the p-value. With a two-tailed test, there are two possibilities. That is, either the test statistic ends up on the left-hand side like it does here, or it ends up on the right-hand side if we'd had a positive number. For a left one, as we have in this case, notice my z is on the left. So we could calculate the area here, this shaded region, not the whole shaded region, but the left tail. We could calculate that with a norm.s.dist of negative 1.25, comma true. But we're supposed to be calculating the area of the entire shaded region, not just the left tail. And since the two tails are supposed to be the same size, all we have to do to calculate it is to do 2 times norm.s.dist. And even though we have a nice number, it doesn't hurt to cell reference it, because again, that doesn't happen very often. So 0.2113 for my p-value. Now, just to note, let's suppose, even though I know this didn't happen, let's suppose we had gotten positive 1.25. Then I would have left my z on the right-hand side, and I would have said that the p-value equals, it's still two-tailed, so there's still two of these that I'm going to calculate. But since it's on the right-hand side, we would need the complement rule. And it would have happened that we got the same number because negative 1.25 is symmetric to positive 1.25. So with a two-tailed test, you will need to double that dist command, and you may or may not need the complement rule. As a general case in step 4, you should ask yourself, do I need to double? And if it is two-tailed, then you do. And then do you need the complement rule? And if you've got the right side, in this case, depending upon whether it was the blue version or the red version, but if you've got the right-hand side, then you do need the complement rule. So for step 5, our decision, 0.2113 is not less than 0.1, the alpha, or the level of significance. So we should fail to reject the null. Please make sure you never say fail to reject and then don't tell me what you're rejecting, because some people mean fail to reject the claim or fail to reject the alternative. So unless you tell me the null, I don't know what you mean. And then my interpretation, again, probably the hardest step. So we start with the level of significance. And we say what we conclude. And in this case, it's a proportion question, not a mean question. And we talk about what we were counting. We were counting proportion of restaurants that have cell phone policy restrictions or cell phone policies. Then the of all statement, of all fine dining restaurants. And since we fail to reject, we should sound wishy-washy, so we should say could be. And the null, remember if we fail to reject, we're saying that the null could be true. So could be 0.2. We don't need to say at most or at least because it wasn't equal to. So just could be 0.2. And then to talk about the claim, believe it was the National Restaurant Association, but I'll double check. Yeah, the National Restaurant Association. Oops, no apostrophe S. And because it was the claim was the null, and because we failed to reject the null, we say that the claim could be true. Going back to those 4 possibilities here at the bottom of this page. There is certainly some differences with means, but that really does give you a good idea of everything going on with hypothesis test. And I don't think means will be shocking if you get these 2 examples about proportions. As always, if you have questions, please contact your instructor.